Hey guys, so it's been a while, but I'm back and with a new series. In this case, volts. So I'm going to teach you how to make a simple volt generator. And in this case, you can change its segments like that. You can change its thickness, and of course, you can change its radius like that. So the first thing we're gonna need here is gonna be a polygon component like this. And for the radius, let's give it a 10.0 number slider. Place it in there. And then let's pick up on a 10 number slider and use it to make our segments. Okay. Yeah, like that. Perfect. Now, this code will essentially branch out into two separate groups. The top one being the two domes, and the bottom one being the arcs themselves. So let's start with the bottom one first. To do this, let's write in explode. Put it there, and let's graph our segments. Okay, and now to do this, the next thing we need to do is add in an evaluate curve so we can get the middle points of all of our segments. / 0.5, and we have, oh yeah, never forget to re-parameterize these. Otherwise you can never get the actual middle point of these curves here. Next up, we need to construct a new plane. We can put this in here. We can add in these segments as an x value, and let's just place a standard z value here to get our needed planes like that. I'm actually going to reduce this so it doesn't get too heavy. About 5, yeah, 5 looks good. Okay, the next thing we're going to need down here is going to be the length. And we want to get our segment's length in there. Let's divide this, let's divide this up with a division component by 2, /2, place this in there, and then we have our divided length. Next up, we want to set up an arc. Place our newly constructed plane in here, and we can see our arcs begin to generate. Add in our divided length as the curve, as the radius. And the next thing we're going to need to do is to build up a surface. And to do this, we just write in surface, actually boundary surface, yeah. We add in our arcs, and then we also pick up on these segments once more, shift, and we have created all these 5 surfaces here. Now the next thing we want to do is an extrusion so that we have something for our domes to subtract. And how do we detect our new z-axes on these planes? So the first thing we're going to need to do here is to get a plane component here so that we can separate these attributes from this entire bundle. Let's add in an SDL line, and we can place our plane both at the start and the direction. Next up, we can place in a number slider. I'm going to put this one at 10.0. I'm going to bring it down to 5. I'm going to place this one here, and then we can connect this one in here. Boom, like that. Also, it's very important, since this will be a complex dome system, to also have the negative value of these. Just be careful that they do not intersect themselves too close to the future wall that's going to be here. But to do that, you can simply adjust these values as you see fit. Okay. And this essentially concludes the first group. So let's pick all of these up. Let's group them all in. You can actually... hold on. Can place these a little bit closer together, so they're not all separated at random. Okay, now for the second group, which are our actual domes, the first thing we're gonna need here is gonna be actually an offset of our hexagon. Let's just hide these in the meantime. Pardon me, pentagon. And so we can pick up on our current pentagon. We place it in there. And now let's use a 1.0, because I do not want to go too far on this thickness for now, to our pentagon, like that, to work as its offset. Next up, we're going to need an explode. This one will be much simpler. We do not need to graph neither our segments nor our vertices. The next thing we're going to need here is a very useful tool, which is the duplicates, or in this case remove duplicates, in which we will remove our duplicate points. And for this one, we add in this one and also this one, since we are working on two domes simultaneously. Here, construct plane. Okay. And we can add in our points at the x-axis. And for our origin here, we're going to need to get our centroid. And to do that, we just need to select the area, pick up on actually either this one or this one, whichever one you see fit, and then connect this in there. Now we have our firmly established centroid. If you in any case get to move this to a different position from the very center of the grid. And for the y-axis, we just need to add in this z-axis, like so. Just like that. Okay, now next up, we're going to need to set up another arc. Let's push it here. Let's add in our new construct. And we wanna add in our points, these ones here, as our two radiuses, like that. Okay. Now, as you can see, we have sort of a duplicate effect going on here, and to fix this, we just need to add in radians. We can add this in here, since this arc system by default will work in radians. We need to have a converter which goes from degrees to radians. Next up, we place in a double dash 90. We put it in there, and now as you can see, our arc system is now much better positioned than before. The next thing we're going to need here is to make a rotation, so that we can make a couple of ruled surfaces. And to do this, we're going to need to go back here to our segments, and we're going to need to add in a division let's add in our segments there. Now let's add in a double dash 360, which means 360 degrees for our model right here. Let's push this a bit up to the front. Let's pick up on our radius, on our result, pardon, and use it as an angle. As you can see now, it's moving in a somewhat weird, into a weird position, and to change this we just need to switch here from radians to degrees, like that. Of course, visually it sounds like nothing is changing, but actually what it did was it rotated 72 degrees, since in this case we are dealing with a pentagon, so that now by picking up on these two elements we can simply do a ruled surface, add in 1, add in 2, boom. And now we have our double dome system set. Of course, in order to make this into a closed brep, we need to join them first. So join breps, or brep join as you see fit, like that. Let's hold on. Oh yeah, pardon. Let's flatten them out like this. Now we have two open breps instead of a large variety of surfaces. Next up, we can now indeed cap our holes like this. We can dispatch these two breps into separate or completely separate entities, and of course let's do a solid difference here. We're going to need to switch the order though, like this, and essentially we finished our domes code. So let's pick up all of these, let's close them into a group, and now except for this one, let's hide all of these. You can see now our dome has been firmly set. Let's just change our segments here to see how it works, like that. Let's put it at 7 for now. Okay, good. Now if we go up to the front of the code, so how do we connect these two? First off, we can hide this one, and we can also hide these ones, which will not be very useful right now. And to finish off, we just add in a solid difference. We add in our top code here, we add in our base code, the arcs, in here. Oh, pardon, forgot to flatten this. And there you have it, a simple code on how to set up a volt generator in whatever kind of crossing you want. I will highly advise to always set this segment value to a minimum of 3, since you can't actually build any kind of volt with 2 segments, only 3, like this example. Okay guys, hope you liked this tutorial. Do not forget to like, share, and subscribe, and I hope to see you here next time.